we are going to discuss about specific heat or latent heat, and so on. We will solve the questions which is based on this particular section. First, we are going to start with specific heat. The word heat which we are using, what is the actual meaning of heat? You all know that heat, it is a kind of energy, right? So can we say that heat and temperature, they both are correlated terms? And now what is the meaning of temperature? Temperature going to tell us about the hotness and the coldness of any substances. So let's see what is the meaning of specific heat. Specific heat can also be denoted by using a small c. Now let's see what is the definition. We can say that the amount of heat required for a unit increase in the temperature of unit mass of a substance is called as its specific heat. So what we are actually going to tell you, the amount of heat required, the amount of heat, that is specific heat, right? If I'm taking 1 gram or 1 kilogram mass, and if you are raising the temperature by 1 degree Celsius, so that means we are actually talking about the amount of heat which is required to raise the temperature by 1 degree Celsius of any substances, and the mass should be 1 gram or 1 kilogram. Right, heat absorbed or released by a substances which is denoted by Q. So we have the formula Q is equal to mc delta T, where m is equal to mass of the substance, C is equal to specific heat of the substance, and delta T, that means the change in temperature of the substances. So here we are giving you a formula, and by using this formula we are going to solve so many questions. Okay, so we can mark star mark because this formula, it's like a very important one. Now let's see, unit of specific heat. I just told you if we are taking a mass, right, and if I'm telling you that the amount of mass or the value which is like 1 gram or 1 kilogram. So if you are raising the temperature by 1 degree Celsius, right, 1 degree Celsius, so the heat, the amount of heat called, the amount of heat which is required to perform this thing called the specific heat. So specific heat, it is also the physical quantity. So we have the unit, and the unit which is written over here, joule per kilogram per Kelvin or joule per kilogram per degree Celsius. Okay, joule per kilogram per degree Celsius. Specific heat depends on the state of substances, solid, liquid and gases. So we all know that there are 3 states of matter. Okay, so specific heat will depend whatever state you are taking. It can be solid, it can be liquid, or it can be gases, right? The substances have a different formation. It can be in the form of solid, in the form of liquid, or in the form of gases. So they having a different kind of specific heat. For example, specific heats of water, ice and steam are different, because water, it is in the form of liquid, ice, like it's in the form of solid, and steam, it's in the form of gas. So water, ice and steam, they all have different specific heat. Now let's see specific heat, which is small c, depends on the state of substances. We are telling you by using these 2 units, okay, calorie, gram inverse, degree Celsius inverse, and joule, kilogram inverse or degree Celsius inverse. We are using 2 units here because we also know that heat, okay, it is energy. It is also going to show us 2 kind of units. It can be measured in the form of calories, or it can be measured in the form of joule as well. Specific heat of ice. Calorie, gram inverse, degree Celsius inverse, it will be going to show you the value, and that is 0.5. In joule, kilogram inverse, degree Celsius inverse, so it will be 2100. Specific heat of water. In calorie, gram inverse, degree Celsius inverse, it will be like 1.0, so like 1. And in joule, kilogram inverse, degree Celsius inverse, so it will be 4200. Specific heat of steam. So calorie, gram inverse, degree Celsius inverse, we will write 0.47, and in the terms of joule, kilogram inverse, degree Celsius inverse, it will be 1970. That means 1970 we can write. So let's see, every time we are actually using different specific heat. Like if we are talking about the ice, the water and the steam, so on, we are using different specific heat. let's see what is the next. Change of phase. We all know that there are three states of matter: solid, liquid and gases. Solid can be converted in the form of liquid, and liquid can also be converted in the form of gases. Why the conversion is going to happen? Because actually we are giving the temperature. This chapter is totally about the heat and temperature. So we are actually providing the temperature. If we are increasing the temperature, we are also able to see the changes in phases. So a substance changes its phase from solid to liquid or liquid to gas at a constant temperature. Okay, so whenever the changes are going to happen, the changes, that means solid can be converted in the form of liquid or liquid can be converted in the form of gases. These changes of phases can going to be happen, but it also going to happen at a constant temperature. This is also a very important point. A substance changes its state from solid to liquid at its melting point. Okay, when the solid will start moving or when the solid will start changing its phase in liquid, it is also going to happen at a melting point. Similarly, a substance changes its state from liquid to gas at its boiling point. So here we have 2 points, melting point and the boiling point. Now the next is latent heat. Okay, we just discussed about the specific heat. Now the next is latent heat. It is the amount of heat absorbed or released per unit mass of a body during the changes of state at a constant temperature. So like I just told you, solid can be converted in the form of liquid or liquid can be converted in the form of gases. So the changes of phases are normally going to happen at a constant temperature, and the latent heat is totally about this. Amount of heat absorbed or released per unit mass. Like if I'm taking 1 gram or 1 kilogram mass of a body during the change of state at a constant temperature, that is going to tell us about the latent heat. So types of latent heat. There are 2 types: latent heat of fusion and the latent heat of vaporization. Okay, so let's discuss first latent heat of fusion. So latent heat of fusion, what is the actual meaning of this? Here we are telling you the heat per unit mass for the solid liquid phase change, it is called the latent heat of fusion. When the solid will convert in the form of liquid, okay, so what we are doing here, we are actually changing phases. We are converting solid to liquid, and that is tell us about the latent heat of fusion. Right, latent heat of fusion of ice, it is given here 80 calorie per gram or 3.36 into 10 to the power 5 joule per kilogram. Okay, it is but obvious, if you have to change the phases, you have to give the temperature, and that is the reason we are telling you the heat per unit mass of for the solid liquid phase. Now let's see latent heat of vaporization. Vaporization, that means here it is very clear that the heat which is going to change, the heat which we are talking about, the latent heat here which we are talking about, it is totally for the conversion when the liquid is going to change in the form of gas. Okay, the heat per unit mass for the liquid gas phase change is called the latent heat of vaporization. The latent heat of vaporization of water is given 540 calorie per gram or 2.27 multiplied 10 to the power 6 joule per kilogram. Okay, you just have to remember this point, because we just discussed about the latent heat, and I told you that the latent heat of ice and the latent heat of water, we also told you about the numerical value. Okay, we just tell you about the magnitude of latent heat of fusion and the latent heat of vaporization. Alright, now let's see. We just discussed about the specific heat and the latent heat. Okay, I just told you about the formula when we told you about the specific heat, that there is a formula: heat absorbed or released by a substance, Q is equal to mc delta T. So we will solve the question which is based on that formula also. We have a very first question. The question says that 500 gram of hot water at 60 degrees Celsius is kept in the open air till its temperature falls to 40 degrees Celsius. Okay, here the mass is given. So we can write here mass of the substance. Right? We can clearly write Mass of the substance small m is equal to 500 gram. Right. Can we change this gram into kilogram? Because when we look at here, we just have to understand that we have to take the units in a proper manner. So we can convert gram into kilogram. We all know that 1 kilogram is equal to 1000 gram. Right? We all know about it. So can we convert gram into kilogram? Yes, we can easily convert the value. Can we write here 1 gram is equal to 1 upon 1000 kilogram. Now we can write 500 divided by 1000. So we can get 0.5 kg. Now we have the mass, right? We also have the delta T. Delta T, that means change in temperature. 60 degrees Celsius, and then it will fall down, and now we have the T2, right? If I'm writing that here 2 temperature, I just have to find out the delta T, that means change in temperature. We can easily able to write 60 degree minus 40 degrees, so it is like 20 degrees Celsius. Right. Now calculate the heat energy lost to the surroundings by the water. We have the formula Q is equal to mc delta T. We have to find out the value of Q. We all know that here we are talking about the water. So the specific heat of water, it is also very easy when I am writing here. M is equal to 0.5. The specific heat of water, it is 4200. Right. Now delta T, it's 20. Okay. We just multiply this value. We can remove the sign of decimal and write down 10 in denominator. It will be cancelled. Okay. You just have to multiply these values. 5 multiply 4200 multiply 2. We can multiply it like this. 5 multiply 2, 4, and it's 8400 multiply 5. When we multiply this value, it is 8. Okay, it's 8. When we multiply it, we will get 42,000 joule. And then we have to tick on the option number B. Option B, it is a correct answer of our question. So we solve the complete question, and then we can get the complete answer. Okay, and then we can get the correct answer. Option number B, 42,000 joule. Now, let's see what is the next question. The question says that a piece of ice is being heated till it's turned to water and then to steam. So, in short, we are talking about the changes in phases. Okay, whatever conditions we are taking, first we are taking that it is a piece of ice that is in the form of solid, and then we just start giving the temperature, and then it will convert in the form of liquid. Okay, it is going to convert in the form of water, and then again when we are giving the temperature, it will convert in the form of steam, that means gas. Which of the following statement is true? We have 4 options. The first one says that the molecules expand as ice changes to steam. So actually here the statement saying the molecules expand as ice changes to steam. You all know about the unusual behavior of water, right? And that is the reason we will mark cross sign here. Now here we are actually talking about the changes in phases. Okay, whatever phases we are taking, solid, liquid and gases, we are showing you the conversion. We are actually going to change the phases. The molecules move faster as ice changes to steam, and yes, here we are actually rising the temperature, and we all know that whenever we are giving the temperature to the substances, they actually start moving. Okay, when they start moving, why they start moving? Because they are actually gaining the energy. When we are providing the energy to the molecules, they will start moving faster. So when ice will going to change in the form of steam, the molecules will start moving faster, and that is the reason we are going to tick on the B option. The B, it is a correct answer of our question. Now let's see what is the next. Which one of the graphs shows the correct change in temperature over time when water is boiled? So what we are doing here, we are giving the temperature to the water, and then we will find out water start boiling. So we are giving the temperature. Here we have 4 graphs, and the graphs will be like in between temperature and the time. Okay, we have temperature and the time graph. We can write here time. So here the question says that the correct change in temperature over time when water is boiled. So if I'm taking one object is right now in the form of a solid, okay, and then we are giving the temperature, it will start gaining the energy and then it will show us the changes in phases. So here we have to tick on the option number C. The temperature will also start rising up, okay, and C graph actually tell us about the statement, the question which is given here. It is going to tell us about the correct explanation. So we have to take option number C. Okay, when we are giving the temperature, the phases are changes and the phases are going to change and so on. The temperature will start increasing and this graph is in increasing order. Now the next question. How much amount of heat is required to raise the temperature of 100 gram of water from 30 degrees Celsius to 100 degrees Celsius? The specific heat of water is 4.2 joule gram inverse degree Celsius inverse. So let's solve this question. The mass is given, right? M is equal to 100 gram delta T. Okay, 30 degree Celsius to 100 degrees Celsius. So we can also find out the changes and it is like 70 degree Celsius. Okay, specific heat of water it is also given. C is equal to 4.2 joule gram inverse degree Celsius inverse. Now we all know that Q is equal to mc delta T. Put the values in the formula. What we are taking here, C is equal to 4.2 joule gram inverse degree Celsius inverse, and that is the reason I didn't change the value of mass into kilogram. Okay, I just place the same value which is given in the question in the terms of gram. 100 multiply 4.2 multiply 70. Right. Now, when we multiply it, when we look at all the options, we will find out that answer is given in the form of kilojoule. So, whatever answer we will find out, we actually have to convert the value in joule. Sorry. Whatever answer we are going to find out, we actually have to convert in kilojoule as well. So, on solving this thing, we can find out that it is actually 29400 joule. Okay, now we will convert joule into kilojoule. We all know that 1 kilojoule is equal to 1000 joule. Right? So, now what we have to do? 29400 divided by 1000. In short, 29.4 kilojoule, and let's tick on the option number 2. Option number 2, it is the correct answer of our question. Now, let's move on the next one. The next question which is given here, how much heat is required to raise the temperature of 100 gram of water from 5 degrees Celsius to 95 degrees Celsius? Again, it is a very simple one. The answer is given in kilojoule. So, we have to convert the value as well. M is equal to 100 gram. If you want, you can also convert the values. Okay, you can also convert it like 100 upon 1000. So it can be right 0.1 kilogram. You can also use 100 gram or 0.1 kilogram. But if you are using 100 gram, you have to take 4.2 as a specific heat. And if you are taking 0.1 kilogram, you have to write down 4200 as a specific heat. Like units are important, okay? M delta T, so it will be like 95 minus 5. So we will get, it's like 90 degree Celsius. Right, again we know the formula. Q is equal to mc delta T. Look at the options. We have to find out the value in kilojoule. M is 100, okay, and 4.2 multiply 90. You can remove the sign of decimal and write down 10 here. 100 multiply 42 multiply 9. When you multiply this value, you can get 92, okay. You can multiply it like very simple one. 42 multiply by 9, 9 to 9. If we multiply 9 by 2, it will be like 18, 8, okay. 9 multiply 4, 36, 36 and 37. Okay, it's joule. Now, the answer which we find out, it's in the form of joule and we have to convert the value in kilojoule. So, we can write down 37800 divided by 1000 and in short 37.8 kilojoule. It is the answer, and then we will check on the option number C. Option number C, it is the correct answer of our question. So everyone, I hope now it's clear to you. We just discussed about the question, and I hope it's clear to you how can we solve the questions. Okay, try to solve the question by your own and it will be very easy for you if you understand the concept. So thank you so much.